Okay, so if the keyword class is used when we create a blueprint for an object, if we think of a class as a blueprint for an object, the best way to think of an interface is as a contract that a class will have to fulfill. So if I create a new class, file, a new interface, I'm going to call this interface my contract. And inside of this contract, instead of implementing methods like we do in a class, we're just going to declare methods. I'm going to say public int return. Let's say compute. Let's make it a double. Public double compute area. And I'll declare another method, public double compute perimeter. And area and perimeter, that's probably enough. So this is my contract. Now, if I create another class that implements this interface, so I'm going to create a new class, and I'm going to call this class square. And I'm going to say square implements my contract. As soon as I say that it implements my contract, I get red lines underneath the class name. And if I hover over that for a second, it says the type square must implement the inherited abstract method, my contract. So essentially, the contract, these methods are thought of as abstract because they don't have implementations yet. They're only declared. They are not yet implemented. And so if we implement it, we sort of inherit those unimplemented methods. And it says, you've got to do one or two things. You have to declare yourself as abstract, or you have to implement them. Those are your only two options. And typically, what we're going to do is add the unimplemented methods. And so if we add the unimplemented methods, Java or Eclipse is going to put in these stubs. These stubs are just basically, they're do-nothing methods. They satisfy the terms of the contract without doing anything really interesting. All right, so a square. A square is going to have a size. So I'm just going to say, all right, my square is going to have a private double size. When I create my square, I will initialize it. I'm going to say public square double s size equals s. Got to initialize the instance variables. And then when we compute the area, what's the area of this square? Well, the area is the size squared, right? Size times size. And what's the perimeter? Well, it's 4 times the size, right? So now I've got a square. It implements the contract, and therefore it must have a compute area and compute perimeter. It must have compute area and compute perimeter methods. Great. Well, let's create another class that also implements the same contract. So we'll create a new class. We'll call this one circle. And under interface here, I can go ahead and list, and I can add an interface and choose interface. I'm going to say my contract. Oops, I start typing it and there it is. I can click it and go OK. and finish. And if I do it right at the creation, it just goes ahead and adds the unimplemented methods. So a circle, it's going to have a private double radius. It's going to have a constructor public circle int r, and radius equals r. Now if I want to compute the area, what is the area of a circle? It's pi r squared, right? Math.pi times radius times radius. If I want to compute the perimeter, why is it saying, okay. Every once in a while, this thing was underlining this thing saying that there was an error. Every once in a while, if you have not saved your files, it will do that. So if you just hit the save, if you're getting underlined errors and you don't think you should, hit the save all button and see if they disappear. So how do I compute the perimeter? The perimeter is pi d, right? Pi times the diameter. But I don't have a diameter. But I do have a radius, and the radius, the diameter is just 2 times the radius. So I'm going to say math.pi times 2 times the radius. Okay, so now that I have two things that satisfy the contract, let's create a method inside of main. I'm going to say public static double sum the area. And it's going to receive an array list of type my contract. You say, that's weird. And I'm going to have to import array list. And I'm going to say double total equals 0, and then for each my contract C contained in R, total plus equals C dot sum the area, C dot compute area. So when we get, and then I'm going to return total. So when we get inside this method, it's got an array list of stuff. And it doesn't exactly know what's inside that array list. It doesn't know if it's a circle or a square or what it is. But it does know that everything in that array list satisfies the contract. And so inside of a square, we might have, oh, even if I made this public size, okay? I get inside of main, if I pull something out of that array list, I can't access the size variable because inside this method we don't know for sure that it's a square. It might be a circle. But what we do know is that because it satisfies the contract, it has a compute area method that returns a double. Therefore, we can add that area to our total, and we can calculate the total of all the area of all the different shapes. And so I can say inside of main something like array list of my contract stuff equals new array list of my contract. So it's an array list of what? It's an array list of things that have satisfied the contract. So that's all the stuff in that array list has got to satisfy the contract. So since a square satisfies the contract, I can stick that in there. I can say stuff dot add new square of size, oh, I don't know, 3. And stuff dot add new circle, because circle also satisfies the contract. And then when I print out, I'm going to call my SumArea method, and I'm going to give it the array list of stuff, and it'll give me the total area of all the objects inside of that stuff array. What is the area of the square? Well, it's 3 squared, that's 9. Oh, I don't know what the area of a circle with a radius of 5 is. Let's see. So the circle, well, must have been big, yeah? Radius of 5. Oh yeah, that's a big radius. 5 pi r squared. R squared is 25 times pi. Pi is 3.14. Okay, well, a little over 75. And then 9, so 87. Yeah, that's about right. It worked. I believe it worked. So what is an interface? It's a contract that must be satisfied by all implementing classes. Methods are declared but not implemented in the interface. Implements. Classes may implement many interfaces, but may only extend one other class. So what do I mean by that? If I want to, inside of square, it implements my contract. I can also implement the mouse listener interface. Of course, then we would have to import mouse listener, and we would have to add the unimplemented methods. A mouse listener is something that can listen to mouse events, right? And so the contract is that it must then have methods that are able to handle those mouse events when they occur. It may also implement the key listener interface. If we're going to implement it, we have to import it, and we have to add the unimplemented methods. It might also implement the comparable interface. Oh, comparable to what? This is a little bit strange. A square would be comparable to a square. add the unimplemented methods. The unimplemented method is compared to. This allows us to sort things. The compare to method should return 0 if the two objects are equal, 1 or -1, depending upon which is greater. Don't need to go into a lot of detail on that right now. We may eventually get to a little bit more detail of the comparable interface. We've definitely used mouse listener and key listener, and this is the first time we have ever created our own interface and implemented it. Abstract. An abstract class may implement interfaces or declare methods without implementing them. So an abstract class is like a hybrid. It's half interface and it's half class. There are occasions where you would like to implement some things in the superclass, but not all things in the superclass, right? So if you make the superclass abstract, then you can implement some of the methods. I'm going to use the example. Public abstract class square implements my contract. Maybe I want to implement the compute area method, but not the compute perimeter method for whatever reason. I don't know. There are occasions where we would like to implement some things but not others. And in that case, we make an abstract class. Abstract classes can, like interfaces, declare with methods without implementing. Okay, except that they must add the word abstract to those methods. I won't do a whole lot with abstract classes. The main thing is that when you see that alternative, there are two solutions when you implement an interface. It gives you an error message and it says make the class abstract or add the unimplemented methods. The advantage of making it abstract is that you don't have to implement all the methods. The disadvantage is that you cannot create an instance or an object from something unless all of the methods, all of the declared methods are implemented. An abstract class may implement interfaces or declare methods without implementing them. It is impossible to create an instance of an interface or abstract class. Okay, so that's extends, interface, and implements. It's a lot of information without a lot of application, right? We dove deep into implementing programs. In the first semester, we're getting really deep into learning the definitions and seeing little examples without a real practical application. So at this point, you may be bored with not having practical application and want to go back to projects. And hopefully, at this point, when I go back to explaining a project, you won't be as overwhelmed as you were first semester. And so that's why this is a year-long course. Hope this is all useful to you. Please keep watching the videos. This is powerful stuff. It is amazing. It's exciting. I hope that a lot of it is starting to come together for you. If you have any questions, as always, please send me a Canvas message. I'm more than happy to try to answer questions the best of my ability. Thank you.